Sailun is a Director of Research Program and also Program Director of Computing Science Program at the University of Glasgow. He was previously Senior Scientist at Philips Research. Professor Kyo received his PhD in Computing Science from Imperial College London. So let's welcome Professor Kyo Sailun.
Thank you, Elle. Let me share my screen. Okay. Thanks for the invitations to talk about emerging trends in intelligent edge computing. I think it's a good opportunity for us to share what we have been doing in the academia, how we can bring all this research into the industry and make it happen. Right. Before I talk about to begin my talk, maybe I'll give a brief introduction about University of Glasgow. So a lot of you may know that University of Glasgow is based in Scotland, and it's actually the fourth oldest university in the English-speaking world, just right after Cambridge, Oxford, and St Andrew. We are a multidisciplinary research university. We have very strong research output in that 81% of our research are actually judged internationally with excellence. In terms of university ranking, we are actually ranked in the top 100 university in the world. The university has also expanded its footprint outside Scotland through its transnational education. In particular, Singapore is the first country where we established a partnership with the Singapore Institute of Technology in 2011, the fifth autonomous university in Singapore, to offer Glasgow degree outside the UK. In the past 9 years, we have already graduated more than 2,000 students in Singapore in the areas of aerospace engineering, computing science, civil engineering, mechanical engineering, and nursing. In addition to this undergraduate degree program that we are also offering MSc and PhD program in Singapore. Later on in 2013, Glasgow established a Glasgow College with UESTC in Chengdu to offer electrical engineering. And then later on in 2014 to Nankai University in Tianjin to offer some business-related postgraduate degree. A little bit more about University of Glasgow Singapore operation here. Okay, as you can see, we are also actively working on research projects in Singapore. And mainly we are focusing on 4 different themes, namely the livable cities, which is quite aligned to the Smart Nation initiative in Singapore, Industry 4.0, smart manufacturing, healthcare, and also sustainability, right? There are currently about 15 faculty members here in Singapore, and we are working on some research that are related to IoT, cybersecurity, AI, data analytics, energy management, 5G connectivities, sustainable construction, and unmanned autonomous vehicles. In today's talk, I would like to share my view and experience in intelligent edge computing with the audience. So I'll first go through the evolution of computing, and then example of application of edge computings that are happening now. And then we also need to know what's important to understand, what are the enabling technology. I think Terence mentioned about AI, connectivities, the hardware accelerator that you may need in order to make edge computing, intelligent edge computing a success. And then I'll conclude my talk with the future outlook. If you look at the evolution of computing, when the computer was first invented, it was a huge machine occupying a large space, right, mainframe computers, and you require physical access to the machine. So most of the computations are mostly centralized, okay? And then when it comes to, the invention of PC, personal computing, then we started to see, there are some decentralization where we have some little processing on our PC sites, okay? So in addition to the mainframe processing, we also have decentralized processing on our personal computers. Not until when the internet is invented and also the TCP/IP protocol invented, then we actually enable machines to talk to machines already, right? So clients or PC can talk to server, and the server can do computation, heavy computation for you. And then the clients are typically a very thin client with much less processing, right? And when storage becomes very cheap, processing powers become very cheap, right? Then we also see a concentration of the need for data storage, right? And then there comes the cloud computing, where you have all the data are stored centrally in the cloud, and with the wide availability of internet, the data can be accessed anywhere and anytime. And then with the AI itself, you need a lot of data and computational power to do all the heavy training, right? This AI training process is actually done in the clouds for faster processing. Then we comes to this idea of Internet of Things, right? It's a buzzword where all the things around us, whether it's sensors, actuators, or even edge devices, are deployed in the field to do environmental monitoring, or even to do factory to do all the monitoring and do predictive maintenance, right? So we also see there's a slow paradigm shift towards centralized processing, from centralized processing to the decentralized processing at the edge. Okay, so we then start to look at can we get instant response time from the machines that we're interacting with, and is it also possible to reduce the transmission of data, right? So that because of limited bandwidth, the more data that we are generating, it is just not possible to transmit all the data to the cloud for processing, right? And there's also some security issues that we may want to take into account, because if you do the processing at the location where the data is generated, then at least the data didn't leave the device itself. Okay. I think Terence also mentioned, the number of data is growing very, very fast. Okay, if you just look at the number that's generated by your sensor data, it is about 60 times faster than your traditional business data. Okay, and a lot of time, all this raw sensor data may not be so useful, because these are raw time series data. We just want to look at a specific window, and then from this raw data to derive certain insights. Right. If you transfer all this data to the cloud, essentially we are just wasting our bandwidth as well. Okay, human data is also an important factor. It is growing about 10 times faster, right, than your traditional business data. So just imagine your mobile phone when you need to unlock your mobile phone using your facial recognition, right? Area of this image, if you were to send it to the cloud for recognition, then it's consuming the bandwidth. So if we are able to do it locally on your mobile phone to do your facial recognition and then unlock the mobile phone locally on the device, then it's faster, and it also reduces the need to send the data to the cloud. Okay, I think with the invention of 5G in the future, right, we will see that devices will be able to interact with each other, right? So with that, every time when you want to do any processing, right, if in the traditional approach, you have to send your data from your device to the cloud, and then you get the results back from the cloud. So in this way, they actually incur certain kind of latency, right? So there are applications like autonomous driving that require instant response time, right? You need the device or the car to make instant decisions, right? You can't really send the data or the videos that you've captured to the cloud, and then the cloud come back with the result to tell you turn left or turn right. Okay, so the latency has become a bottleneck in a way, and that's why edge computing is actually important for some of this specific application. And the other important factor that we think is important is the security and data protection. Okay, so there are certain rules and policy that require the data collected to be residing in specific countries or jurisdiction. So therefore, in order to apply to this GDPR or PDPR, for example, edge computing is actually the right solution, because it ensures that the data is processed, stored, and analyzed at the point of the data collection. So it's not, transmit out of your jurisdictions. If you look at the some sample applications that are around, okay, that embraces edge computing. So in Singapore itself, we have the Smart Lamppost Initiative, right? It is not only containing the sensors, to monitor the environment, but it also has capabilities to do better incidents response and public safety, right? So in order to do this, this means that there will be some intelligence built in on your smart lamppost, and then images captured by a camera in real time has to be processed instantly, so that situation can be dealt with, and then scene understanding can then be taken place right away. Okay, so that's one of the example of edge computing with intelligence in Singapore. And if you look at smart factory, right, IoT sensors are deployed to automate the production lines. Your cobots, your trucks, and your robots will make use of computer visions in order to intelligently pick up or grab components to be assembled. And for the navigation of the robot, you also need intelligence built in for the robots as well. Okay, and of course, in the autonomous vehicle domains, right? So LiDAR is used for mapping to detect range of the computer ranging to an objects, and you have video cameras to do all the object recognitions, pedestrian recognitions, and you have all the other sensors, ultrasonic sensors, autometric sensors to do the object detections as well, right? So this autonomous vehicle itself is actually a complex edge device by itself that is able to run autonomously and do all the processing of the data and the images captured. Okay, so there are other edge computing applications, for example, the smart retail, and also using drone for delivery. Many companies have started to experiment with this drone delivery, where the drone has to be autonomous, intelligent, such that it can navigate itself to the destination without requiring any continuous connectivity to the cloud. So my colleague Hendrik will talk about drones application in the later part of his webinar. In our opinions, I think Teres also covered what are the enabling technologies that are required to make this edge computing, intelligent edge computing a success. So first of all, of course, you'll need the artificial intelligence or machine learning, right? So this is like the brain of your edge computing systems. Okay, by having the data, it's not enough because data are just plainly raw. So we need this intelligent engine, to make sense of the data and then to make accurate predictions and execute the correct actions. Secondly, security and privacies are also very important. If the same intelligent device using the same AI model and deployed across thousands of devices, if there's a hack or a compromise on your AI models, then that means that all your edge devices will be compromised. I mean, it's similar to your operating systems updates. Everyone's running Windows or Linux, for example, right? So if there's a security fix that needs to be done to be patched, right? This fixes needs to be propagated to all the install base, right, in order to update your operating systems, right? In edge computing, in order to enable your edge computing, we also need probably specialized hardware. I think, for example, AI accelerators that need to be built in. We also need to do some kind of optimization on our software in order to run on devices which are typically quite constrained and less powerful compared to the cloud, right? Finally, the 5G connectivity. Of course, devices will need to talk to each other to relay their data. 5G connectivity will enable devices to talk to each other more effectively with a greater bandwidth. We also think that the other important component is also the management of your edge devices. How do we properly manage them to update these devices just like your operating system home or your firmware, right? So we should have an efficient way to collect the new data from your edge devices and then to retrain your AI models and then to update the models and redeploy them back to the edge devices over time. So the first applications that we are interested in is, if you look at AV, AV is essentially a complex edge device with a super intelligence, right? So autonomous vehicle here means that it has the full control of the vehicle by AI without any human interaction. So this is similar to your SAE level 5 defined here, right? So even when you have a critical situation or you have an unseen, unknown situation, right? This will all be handled by the AV itself. So the driver cannot interfere, right? So all these, the AV will need to do pedestrian detection, for example, in this case, in the video here. You also need to detect obstacles, and you also need to do avoidance of obstacles, right? All this has to be done instantly on the AV itself, and the intelligence has to be built in there, right? So that's the complex edge device with super intelligence that people are developing. Currently, University of Glasgow, Singapore, we are working with Movita in Singapore to look at the risk of an AV in real time. So we're having an aim to actually improve the safety of AV by looking at or to calculating the risk assessments in real time when the AV is moving. My colleague in Glasgow is also working on a project to actually deploy an image classifier on satellite, because if you look at the satellite images that you obtain, right, it's huge, okay? And in this case, the satellite itself will be able to take images, but images are actually extremely very small. So to recognize or to detect this object is actually quite challenging. So instead of transmitting all these satellite images to the ground stations, what they are doing is actually to embed an image classifier on board the satellite itself so that you can automatically detect the objects and then transmit the detected object image down to the ground stations. Right, so that will actually save them quite a lot of time and also the bandwidth for transmitting the images down to the ground stations. So this is a project that my students did to investigate the feasibility, of deploying a facial recognition systems on an edge devices such as Raspberry Pi. Okay, so we explored quite a number of facial recognition models and evaluated their performance, whether we can run it with good accuracy on the edge devices itself. So if you look at the current safe entry system in all the shopping malls, what they do is that they only do the facial detection. Okay, they don't do facial recognition. So the facial recognition here is that we are trying to detect and recognize who you are. It's meant for authentication purposes, right? So that once you are recognized and authenticated, then access is granted, right? So in this case, the project, we do not have any connectivity to the cloud. So everything is deployed on the Raspberry Pi. And there's a AI accelerator, USB AI accelerator that we use, and we wanted to compare their performance. So if you look at the three graphs here, right? So this is the regular models, right, that we use based on TensorFlow, right? They are pretty much very high accuracy, okay, and inference speeds are pretty low, okay. When we run it, the same model, we run it on the Raspberry Pi itself, okay, converted it into a TensorFlow Lite model, right? We run it on Raspberry Pi without any accelerators. We can see that there's a degradation of the inference speed, so it takes longer time, okay, to do the inference, okay, to recognize the face. But in terms of the accuracy, they are still pretty much okay, okay, still at 0.8, 0.9%, okay. But when we included accelerators, okay, a small accelerated USB accelerators, then we can see that the red color mobile nets, right, the accuracies retain, and then the inference speeds also sort of retain compared to the original one, right? So this also shows that having a full-fledged facial recognitions deployed on an edge device is strictly possible, okay, nowadays. Okay, and when we compare a edge deployment with the cloud deployment, right? If you look at the system response speeds, okay, the 0.036 here is purely the response rate from your facial recognitions. The additional 2.85% for the cloud deployment is an overhead that you need to send your image to the cloud and then get the results from the cloud. Right. So if we are able to actually deploy a full facial recognition on the edge itself, we can actually save on the communication overhead, and to provide a more instant response to the user. When we try to deploy a lot of these AI systems, either in the cloud or on the edge, there's also this thing, security is very important, right? Even most of the AI machines, for example, the facial recognition, object recognition today we have, it has been shown that AI can be attacked using, for example, adversarial examples. By manipulating your physical space, and you can trick the object and facial recognition system. So for example, in this case, right, the classifier will classify this as a banana, right? But by specially generated image of a toasters, okay, this one, right? It becomes, the classification will return you result that is a toaster, okay? So you are able to actually attack the systems. In this particular case, these two guys, So what they did is that they actually developed a specially generated patch. Okay, so this patch, when you have it, as part of your body, right, you are able to evade the detections, the person detection. So this guy is detected as a person, but the system is not able to detect that this guy is a person itself. Okay. So the other work by this guy is to tamper with the stop sign. Okay. So the original stop sign without any tampering, it can be detected correctly, 99%. But if you vandalize, or you have a certain patent, so you vandalize the stop sign physically, right? The stop sign is actually cannot be detected by your object recognition, right? It is detected as a person in this case. Okay, and the last example here that I gave is this lady. She was initially detected as person 1. Okay, but the interesting thing is that by specially generated a patch, okay, you can perform a dodging attacks. So by attaching a patch here, okay, so the facial recognition will recognize this lady as another random person, not person A anymore. Okay, so these are some of the adversarial machine learning that could happen to all the AI systems. And when we deploy it to either in the cloud or on edge devices, we need to ensure that there are properly addressed. Another more important or more severe attacks is actually the impersonation attacks. For example, Lugo, right? By generating and 3D print 3D glasses, okay, and wear it. So the facial recognition will actually misclassify him as John Malkovich. Okay, so they were able to actually look at the models and the training data sets, and then come up with attack models in order to compromise the systems. And recently, my students have also designed a structured approach, to generate an adversarial patch that can be embedded on any facial images, okay, to launch an impersonation attack, right? So this is a specially generated patch that we can be generated that is targeting to a targeting user. So whichever image that contains the patch, the facial recognition will automatically classify as the target user. So in a way, anyone who got hold of this patch will be able to launch this impersonation attack. Okay. I also mentioned about hardware and software optimization, right? What we typically do when deploying AI models onto the edge is that, we want to actually shrink the machine learning models so that it can run on edge devices without compromising the accuracy, right? Typically, we will run quantizations in a way that, we reduce the resolution of input images from 24 bits to 1 bit or 8 bits, or we convert the floating point to integer for processing, from 32-bit processing to 8-bit processing, in order to ensure that the final model that is running on the edge devices consume less power, less memory requirements, but retaining the model accuracy. So there are various AI chipsets that's available in the market, AI accelerators to be used and integrated with our edge devices for all these applications. In terms of storage, right, devices may have limited storage. Your sensors, your edge devices may have limited storage, but it's also possible to actually set up an edge cloud that is co-located with the sensors in the same network using many Raspberry Pi devices. So in Glasgow, we actually pioneered the Raspberry Pi cloud that is portable, reliable, and secure. And we've shown that it is possible to just set up your own cloud using commodity hardware such as a Raspberry Pi and put them into Lego blocks in your premises as data storage and computation. Finally, I'm in the opinion that intelligent edge devices need to be updated, upgraded over time. So you can't just deploy your AI model to the edge and let it run throughout its lifetime. Okay. So what this means is that the data collected from the devices typically will need to be fed into the AI model for retraining, and then in order to update the knowledge base, or also to improve its accuracy, and finally redeploy onto the edge. So this will be a continuous processes, and this management life cycle must be handled properly and carefully to ensure that these edge devices are reliable, efficient, and most importantly, safe. Okay. So these are the two other interesting edge applications that I found on internet. So in Philippines, researchers have actually deployed AI-based solutions to monitor and characterize and to analyze a coral reef resiliency. So what they do is that they deploy this with, I think it's an Intel AI accelerator here, to actually classify your fishes, to detect and photograph fishes that pass by, and counting and classify the marine life. Okay, so the data is then sent to the surface dashboard for further actions. And in Borneo, I think researchers also deployed a solar-powered Raspberry Pi to listen to the sounds in the ecosystems, in the forest ecosystems. So this is actually meant to catch poachers and to stop illegal logging. So all these soundscapes can help scientists to monitor whether there's any degradation of the ecosystems. Okay, so these are some of the more environmental projects that make use of the edge computing. Finally, my last slide. So I think intelligent edge computing is already here with 5G connectivity, with IoT deployment in our environment, the maturity of AI, machine learning, and deep learning. We'll see a lot more decentralized computing, edge processing, and distributed computing being rolled out in the future. Researchers are now looking into more advanced systems and techniques, such as something we call federated learning, where data resides on where it is generated, and the AI training is done at the edge itself. Okay, so the generated models are then aggregated, so without compromising the security and privacy. But I think cloud will continue to exist, and edge and cloud will coexist in this new world. Finally, we in Singapore also look forward to collaborate with the industry partners. So we actually run a few industry postgraduate programs here in Singapore, and also some research project with industry. For our students, we also encourage them to actually work with industry to get real experience through integrated work study program and the students capstone project. Thank you for your attention. I think that's all I have today.
Thank you so much, Simon. We may have some questions coming in with all the edge applications you shared.